Okay, we have these two systems of equations, and I look at them and I say, well, you know what? If I found the x and y intercepts, things are going to come out very empty because 3, 2, 6, 4, 6, 12, they're all divisible. So I could switch them, make them into point slope formula, and that'd be fine. But I think this time I'm going to find the intercepts. So 0, the y-intercept, and the x-intercept. Because if I put in 0 for x, I just divide both sides by 3, and I get 0, 2. I get 0, 2. If I put in 0 for the y part, I divide both sides by -2, I get -3. Again, this is where I see a lot of mistakes. You'll divide by a negative number and keep it as a positive. When I grade your test, a very common mistake, you would have said 6 divided by -2 was a positive 3. Guys, got to be careful with that. You lose a lot of points because of the arithmetic rather than the algebra. So I have these 2 points. Over here, again, I'm going to find the intercepts. My intercepts. And so if I put in 0 for x, divide both sides by -6, by -6, -12 divided by -6 is a positive 2. Positive 2. I put in a 0 for the y, divide both sides by 4, -12 divided by -4 is a -3. Right away, do we know what point we're going to intersect at?
Parallel.
They're not. No, they're not. We don't know if they're parallel.
Yeah.
Shh.
Already got it. Same slope.
They both have the same slope.
MXB.
Well, where? Okay, so you take the mx plus b form. All right, but they have a point in common.
Same X. That's 2 points in
They have
common.
2 points in common,
Oh.
which means they're not parallel lines.
Perpendicular.
They are the
Neither.
same line. 0, 2, here's, okay, so 0, 2, -3, 0, that's the line, that's 1. They're both the same line, because let's look at this. So if I solve this in mx plus b form, I add 2x, I get 3y equals 2x plus 6, which means y equals 2/3 plus 2. Second one, -6y equals -4x minus 12. When I divide both sides by -4, I get -4 and -6 is positive 2/3
X minus 2.
x. -12 divided by -6 is.
So it was minus 2 plus.
They are not parallel lines. They are the. In other words, we could say, actually, the solution, we could say this. These two systems of equations have every point in common. They have every point in common. Yes, ma'am.
You know how you did the second line or whatever? You did, yeah. You know how you got -12 divided by 4? How'd you get 2? 3.
-3. All right, so when one point is the solution to a system of equations, we say this, the system is consistent and independent. By the way, look at your something like this should be your illustration of independent and consistent. So when we say independent and consistent, we're talking about two lines like that, where they have this point x, y, and only that point x, y in common.
Where's the
We're talking, these are definitions. This is also in your terms bank. We're going to put this parallel onto your terms, your word bank. Urissa. Sit up. Take some notes, please. Now, parallel lines have no points in common. Therefore, there is no solution to the system of equations. When the lines are parallel, we say the system is inconsistent. Inconsistent. That would be the top of the second column on your word bank. So inconsistent means they are parallel like that. Parallel. So your illustration would be that they are parallel. Shh. Stop. Now, when the two equations for the same line, there are infinitely many solutions. We say the system is consistent and dependent. So consistent that first column means it was consistent and independent. This one's consistent and independent. The second one is parallel, so it is inconsistent. Inconsistent. And our third one, this one, was consistent and dependent. Consistent and dependent because it really was the same.
This is so great. I love math.
Now, we also want to determine whether this system these equations fit. In other words, they give you an ordered pair. Does it fit? And all we do is we substitute in the point into both equations, and basically, do they equal? Do both sides of the equation equal? So this is strategy, is just to substitute the values for x and y into each equation and see if the results are true. If the ordered pair makes both equations true, then it is a solution to the system of equations. So here, we'll do the top one here, the bottom one here. So I have y equals 4x minus 7. Our ordered pair is 3, 5. So I put, does 5 equal 4 times 3 minus 7? In other words, does 5 equal 12 minus 7? 5 does equal 5. So yes, 3, 5 is a solution for that first equation. Pardon?
Hold on, you know what? 5, is that 5 times 12? No, the other one. Yeah.
No, I have it's an equal sign with a question mark above it.
Why?
Because we want, are they equal?
Oh.
Are they equal? And yes, in the end, we find out they are equal. So 3, 5 is a solution for the top equation. What about for the bottom equation? We would say, okay, we have x plus y equals 8. Is 3 plus 5, does that equal 8? And yes, 8 does equal 8. So this point, that point, is a solution for this. could be for one but not the other. So let's practice this one. Let's practice this one. Shh. By the way, the assignment on the notes isn't. I don't remember if I changed it around a little bit, so it may not be the same assignment. So I'd watch it. So determine whether you're given ordered pairs. Look, you guys practice this one. Is that point a solution for those two systems of equations? Is it on those two lines? So the first one, I have 2x minus y equals negative 5. Does 2 times negative 2 minus 1 equal negative 5? Negative 4 minus 1, does it equal negative 5? Negative 5 does equal negative 5. So, this point is on the first line. But to be a solution, it must be on both lines. So the second one, 3x plus 2y equals 3. So we have, stop that, 3 times negative, chair, 10 minutes, please. Negative 3 times negative 3 plus 2 times 1. Does that equal 3? Negative 9 plus 2. Does it equal 3? Negative 7 does not equal 3, so not a solution. This point is not a solution to this system of equations because although it is on the first one, it is not on the second one. 3, oh. Negative 6 plus 2. Well, negative 4 is still not equal to 3. All right, so